In the next few minutes, you'll find out how NASA could be the key to stopping Los Angeles wildfires before they turn into city-gobbling infernos. Sounds wild, right? But here's the spoiler: satellites, specialized drones, and real-time data systems originally designed for exploring outer space are already helping firefighters predict and respond to flames more effectively. This isn't some far-fetched theory. We're talking about actual tools NASA tested in rugged conditions, bridging massive communication gaps in disaster zones. So if you've been thinking, that title's gotta be clickbait, consider it validated. Los Angeles wildfires are notorious for sneaking up on residents and blazing through neighborhoods in a matter of hours. Barely a day goes by during the peak fire season without some ominous smoke plume looming in the distance. Fire departments do heroic work, but they often rely on limited intel, on-the-ground reports, radio dispatches, and a bit of guesswork. NASA, however, comes in with next-level tech. When you can coordinate aircraft, satellites, and rovers on another planet, orchestrating drones above a burning hillside becomes more than feasible. It's a whole new era of firefighting intelligence, an evolution from strictly reactionary efforts to forward-thinking prevention. The heart of NASA's approach is data, massive streams of it, collected from satellites orbiting Earth. Sure, we all know NASA points telescopes at distant galaxies, but they also track shifts in Earth's climate, vegetation health, and atmospheric changes. Combine these insights with local weather data, and you have a blueprint for identifying hotspots before they morph into unstoppable fires. This is crucial when a region like Southern California faces prolonged drought, strong winds, and record-breaking heat. NASA's data doesn't just say it's dry out there. It offers precise, near real-time snapshots of soil moisture, plant stress, and even patterns of human activity that might elevate risk. Once that data reveals a potential danger zone, you don't want to wait until you see flames. This is where NASA's stereo system steps in, short for Scalable Traffic Management for Emergency Response Operations. Picture a portable, rugged internet kit deployed in the middle of nowhere, allowing drones, helicopters, and even ground crews to seamlessly exchange location info. In a typical wildfire, drones and piloted aircraft basically can't coexist. Nobody wants a mid-air collision. But Stereo's integrated traffic management ensures a plane-dropping fire retardant knows exactly where drones are scouting, all while dispatching real-time alerts. It's like an air traffic control tower customized for chaos. Think about the firefight from a boots-on-the-ground perspective. You're racing against time, your radio crackles with partial updates, and wind gusts threaten to shift the blaze at any moment. Now throw in NASA's drone coverage. These flying eyes in the sky beam back thermal images of fire lines, reveal the hottest hotspots, and detect new flare-ups. Instead of an incident commander guessing what's behind that ridge, they get a live feed to their tablet. Stereo's bring-your-own internet approach means connectivity isn't reliant on shaky cell towers. You basically set up your own firefighting network, seeing all active operations at a glance. But NASA doesn't stop at real-time coordination. Beyond the immediacy of a raging wildfire, they leverage advanced satellite imaging to shape long-term prevention strategies. Yale researchers consistently remind us that climate change drives extreme weather, amplifying fire risks in places like LA. NASA has the data to back that up. Patterns in temperature spikes, rainfall deficits, and vegetation dryness help officials identify trouble areas weeks or even months before they catch fire. With that intel, local agencies can plan targeted brush clearance, controlled burns, or early evacuations. It's the difference between always being in crisis mode versus taking the fight to the fire before it even starts. Now, let's talk about NASA's multifaceted capabilities. Satellites like Terra and Aqua capture continuous images of Earth, unveiling hotspots in near real time. When you combine that with local environment stations measuring humidity and wind, you get dynamic risk maps. Fire chiefs can see, in almost a video game-like view, how a fire might expand if the wind angle changes by 10 degrees. Meanwhile, NASA's portable networks keep all relevant teams connected. No more waiting for a spotty radio signal that might not even get through. The result? A more proactive style of firefighting, where you're not just reacting to flames already roaring, you're intercepting potential threats at their earliest stages. If you're finding this helpful, hit subscribe and stay tuned for more ways NASA's tech can protect our planet. A prime example of NASA's real-world demonstrations comes from Northern California, where the Stereo crew tested their coordination tools with WildFire and the U.S. Forest Service. The region's hilly terrain and patchy cell coverage might as well be a black hole for standard communications. Yet NASA's pop-up Wi-Fi network blanketed the fire zone with strong connectivity. Drones soared overhead, planes swooped in for water drops, and every movement was tracked. Rather than drones being grounded when piloted aircraft arrived, everything coexisted safely. Firefighters on the ground also appeared on the digital map, ensuring everyone knew exactly who and what was on the field. Of course, some might argue that wildfires are unstoppable forces of nature, so how much can NASA really do? True, you can't freeze the wind or magically soak entire forests overnight. But you can plan smarter, respond faster, and foresee danger zones. For instance, a NASA satellite might detect an unusual heat signature in a remote canyon. In the past, it could be days before a hiker spots the smoke and calls 911. Now, a specialized alert reaches local fire agencies in hours or even minutes, letting them scramble a small crew or send a drone to confirm. That difference might keep a spark from exploding into a massive inferno. Another huge piece of the puzzle is post-fire recovery. Burned landscapes are primed for erosion, mudslides, and invasive species. NASA's imaging technology can measure the severity of scorched soil, identifying spots at risk for landslides once winter rains come. Meanwhile, academic powerhouses like Yale push for resilient reforestation, planting a variety of fire-adapted species that bounce back quicker, reduce fuel buildup, and better handle drought. By layering NASA's topographical data on top of local climate reports, you can figure out which native plants stand the best shot at thriving under current conditions. Over time, healthier forests mean fewer megafires. None of this is free or easy. NASA's portable communication equipment, advanced drones, and thorough satellite operations all come with a price tag. Local fire departments, already stretched thin, may wonder if new tech is worth the cost. But consider the alternative: repeated catastrophic wildfires that cost billions in damages, displacement, and disaster relief. Over time, investing in cutting-edge prevention pays off in saved lives and preserved property. There's also the matter of training. Sure, NASA has the experts, but firefighting teams must learn to interpret data, manipulate digital maps, and handle intricate drone missions. That requires a cultural shift, one that embraces technology as a standard tool. Public acceptance is another factor. The idea of NASA drones buzzing overhead might raise eyebrows. People could question privacy or fear constant surveillance. It's vital to clarify that these drones are focused on detecting heat signatures, not peeking into backyards. By transparently explaining how the data is used, communities can get behind the program. After all, if a NASA drone warns your neighborhood of an oncoming fire line an hour earlier than it otherwise would, that's a huge lifesaver. Over time, successful incidents, where immediate evacuations and drone guidance avert tragedy, will help cement public trust in NASA-led solutions. Scaling up is the next challenge. Wildfires aren't unique to California. States like Colorado, Arizona, and even parts of the Pacific Northwest face growing threats. Globally, Australia, the Mediterranean, and other hotspots are dealing with epic fire seasons. NASA's blueprint can be adapted. The Bring Your Own Internet system and robust drone coordination tools are portable by design. Imagine an international version of Stereo that local agencies in Greece or Portugal could deploy during their fire seasons. NASA could share the technology, while local responders adapt it to their specific environment. It's not a one-size-fits-all approach, but it's flexible enough to handle diverse landscapes. So, how does this look day to day when a fire breaks out near Los Angeles? Let's paint the scene. A small spark in the brush escalates. NASA satellites register an unusual thermal reading and send an automated alert to both LA County Fire and a NASA operations center. A quick drone launch confirms there's a developing fire. The stereo system kicks in. Firefighters see on their screens that a ground crew is en route, drones are scanning, and a helicopter with water buckets is inbound. Officials coordinate the flight patterns so none of these resources collide. Meanwhile, the system's data feed calculates wind direction, dryness levels, and possible spread patterns. Residents in the highest risk zones get instant push notifications. From ignition to organized response, you're looking at a timescale that's drastically shorter than traditional methods. Don't forget to subscribe for more stories on how space-age tech tackles Earth's biggest challenges. Meanwhile, NASA's real-time imagery reveals the fire is creeping toward a ridge with high winds. If it crosses that ridge, it could roar downhill into a densely populated area. Commanders dispatch extra crews there based on satellite data showing just how hot the blaze is. The drones remain overhead, capturing thermal video that pinpoints the fastest moving edges. With constant updates, you don't wait helplessly. You adapt. Crews pivot from one flank to another as conditions shift. And above all, you're not caught off guard. That might be the single biggest advantage NASA's approach brings, turning guesswork into informed, data-driven decisions. Zooming out from immediate tactics, NASA also pairs with climate scientists to forecast the big picture. Maybe next season looks particularly dire because of an ongoing drought pattern. That knowledge becomes the backbone of budget proposals, urging local governments to invest in more clearing projects or better firefighter training. At Yale, researchers emphasize that you can't separate fire management from broader environmental and social factors. Population growth, outdated building codes, and even insurance policies factor into wildfire risk. NASA's data can highlight which neighborhoods should bolster their fire-resistant infrastructure or consider relocation out of extreme zones. It's a wake-up call for cities balancing economic development against the realities of a changing climate. You might wonder if NASA's expertise distracts from its main missions, like exploring Mars. The reality is, NASA often repurposes existing tech. The same knowledge that helps a rover autonomously navigate Martian craters can guide drones through smoky skies without colliding into trees or telephone poles. The same algorithms that map the moon's surface can measure post-fire damage on Earth. Plus, NASA receives funding specifically for earth science and aeronautics research, which includes projects like STEREO. It's not an either-or situation. In fact, success here could pave the way for stronger machine learning models, advanced robotics, and communication networks that also push space exploration forward. It's a symbiotic relationship. When the smoke finally clears, the conversation shifts to lessons learned. Suppose NASA's drone coordination prevented a potential megafire that might have claimed thousands of homes. That's quantifiable success, but it goes deeper. Post-incident analysis might reveal that some communities still lacked fast evacuation routes, or maybe the drones could only monitor certain sections due to terrain difficulties. NASA examines those gaps, refining protocols. Meanwhile, local leaders set new regulations, maybe a requirement for all new developments in fire-prone zones to follow stringent building standards and keep a 100-foot defensible space around structures. That synergy between data-driven insights and policy can create lasting change. Could NASA's role in wildfire prevention be a model for other types of disasters? Absolutely. Hurricanes, flooding, and even earthquakes sometimes benefit from advanced aerial surveillance and rapid coordination systems. Stereo's portable communication network could just as easily serve areas slammed by a hurricane, establishing a command center out of thin air. One day, you might see NASA working hand in hand with local authorities around the globe, tackling crises with that same methodical approach used for space missions. When you consider how many billions of dollars are lost each year to natural disasters, the cost-effectiveness of NASA's technology becomes even clearer. Of course, it's easy to paint a rosy picture of unstoppable NASA tech. We have to stay realistic. Wildfires are unpredictable, and climate change is accelerating. Even with satellite warnings and drone fleets, we could still face record-setting blazes. The real question is whether we choose to equip ourselves with the best possible tools or stick with outdated systems. The more we refine NASA's innovations and adapt them to firefighting needs, the better shot we have at limiting devastation. This is a battle on multiple fronts: ecological, technological, political, and cultural. NASA can't single-handedly fix every issue. But if you can monitor an entire forest from space, coordinate emergency aircraft, and anticipate shifting winds, you've got a significant head start.